Hi there, my name is Brandyn Callahan.
And I'm Suon.
And although we can't join you in person for the GAS conference in 2020, we're so excited to have the opportunity to share with you some of our work, some of the techniques and some of the tools that we use to create it, and to be with you in this digital environment. So the following presentation was one that we had just given. It's an adapted talk that we gave to Palomar College and Cal State University San Bernardino. And with the incredible gracious help of Ayaoki, we've been able to adapt it and share it with you for the Glass Art Society conference. We hope that you enjoy it. If you have any questions, there's our contact info at the very end of the video. Feel free to reach out. Thanks.
Hey, how are you guys doing? Thank you for joining us. My name is Ayaoki. Today, I am so pleased that finally I'm able to introduce these two talented artists, Suon and Brandyn Callahan. I'm so happy that they are here today to meet us. First, I'd like to introduce Phirak and Brandyn. Phirak and Brandyn have been working together based in Seattle, Washington. Since they met at Future Glass School in 2016. Phirak is a designer and Brandyn is a glass blower. So they come from different backgrounds. But their curiosity brought them together and it was a perfect match. They have been teaching and traveling together to share their knowledge. And recently they were at the Corning Museum of Glass as an artist in residence last November. I feel extremely lucky that I also had a residency there when they were there. This is how we got to know each other. We were sharing a studio space and I was so fortunate that I was able to see their dedication and expertise. It was very inspiring. Some of my students are interested in combining ceramics and glass. And I've seen the ceramics department at Cal State San Bernardino was working on a ceramic 3D printer. So it was a really decisive factor that I wanted to invite them to California. But mostly it's because they are amazing human beings. I really wanted my students and everybody here to meet them. Please welcome Phirak Suon and Brandyn Callahan.
Hi. Well, thank you, Aya. And first of all, getting to know Aya, she is such an incredible person, such an incredible human being. The time that we got to spend together in Corning was super special. And yeah, I wish that we could be in California with all of you guys and touring around, but I'm really thankful that there's still platforms for us to be able to communicate, to share, to talk. And then also there's this kind of added bonus where you guys kind of get to see the unedited version of our studio. And
yeah, behind the scene.
Yeah.
A lot clean up, but
yeah, a little cleaner, but so we'll go ahead and so to kind of the lecture that we're going to give, it's going to talk about my work, about Phirak's work, about our combined work, and also kind of some overarching themes too. And one of the biggest ones that I want to talk about is that there's this kind of this popular notion that technology and craft are opposed, and that technology influences craft in this one-way transaction, and that as the world progresses, as new technologies are developed, that they just change it in this one-way format. And we've had this incredible explosion in the last couple of decades of research into artificial intelligence, robotics, 3D printing. And a lot of people are really worried that their jobs are going to get stolen, especially as makers, as people have these traditional skills. And instead, I'd really like to showcase that it's a transactional relationship, that as these technological innovations come together, that influence crafts and materials, that traditional craftspeople have a lot to say in their innate knowledge of a material helps shape these modern tools and technologies as well. And an example that I really love to illustrate this is the light bulb, that something everyone is very familiar with. So light bulb developed in 1879 by Thomas Edison, and he was this big champion for this idea that inexpensive energy could illuminate the entire world. But one of the biggest obstacles to this early goal was how fast one person could make a light bulb, because all the light bulbs originally were made out of hand. So working as fast as possible, a master glassblower could produce 2 bulbs a minute by hand, which seems really fast if you know how to blow glass, but it's painfully slow when you think about the entire total production of light bulbs in the world. So as light bulb production demand grew, a lot of these larger companies started trying to figure out all these different ways of industrializing production. So in the early era of all this happening, there was a glassblower named William J. Woods that worked his way from a traditional factory education, from an apprenticeship to a master, began tinkering with a lot of these different methods of mass producing bulbs. And was that one day Will Woods was on the factory floor and noticed there was a shovel that was used to scoop up glass that had fallen out of the furnace, and it had worn a hole in the middle of the shovel. And through that hole, when people would scoop up glass would just drop into this natural kind of a light bulb shape. And that inspired him to think about different ways of forming glass that didn't involve blowpipes, any of these other methods that had been tried before. And from this, William Woods and David Gray patented the first ribbon machine for producing light bulbs and other manufactured goods in 1921. So from that top speed of glassmakers producing 120 bulbs an hour by hand, this original ribbon machine could produce a pretty incredible 1,600 bulbs per hour, 24 hours a day, 7 days a week. And in the 70s and the 80s, 15 ribbon machines produced all of the light bulbs that were needed in the entire world. And we have a super quick video. It may seem like it's a little funny, or the video itself slows down and speeds up a little bit, just so you can see, because this is the normal speed. This more modern machine produces bulbs at a rate of 2,000 bulbs per minute, which is 3 million bulbs in 24 hours, which is just mind-boggling. And I wanted to share this with you guys because I think it really illustrates how when you pair a traditional knowledge of a craft and of a material with a little bit of ingenuity, a little bit of modern technology, you can really revolutionize the entire world. So you can see here, light bulbs are just tumbling off this machine as fast as you can watch them. And so much in the same way that Will Woods learned his craft through an age-old apprenticeship system, my own education came from working in the studio and gaining knowledge, person to person, artist to artist, maker to maker. I fell in love with glass when I was 18. Grew up in Portland, Oregon. I was so hungry for experience working in any part of the field, doing anything I could. I took jobs rebuilding furnaces, sweeping floors, cleaning bathrooms, just as much as I could to experience and gain from this, and trying to find better mentors to work from and to learn from. And that led me to, fortunately enough, early in my career, meeting this man here. This is Benjamin Moore, who's a luminary and one of the founding members of the studio glass movement. And he's had a studio, BMI, Benjamin Moore Incorporated, in Seattle, Washington for 30 years now at this point, that has had some of the most incredible artists that have worked out of it. And he had an apprenticeship program for a long time. I don't think it goes anymore. I kind of caught the tail end of it. And working with him was an incredible introduction. This is some of his work. Was an incredible introduction to the Seattle glass community, but it really gave me access to a whole batch of mentors that I was so lucky and fortunate to have. So clockwise from the top left, Deborah Moore, Dan Daly, Aaron, Preston Singleton were some artists that I was getting to work with when I had first started. And for me, it was, I didn't have access to a traditional apprenticeship program like a lot of countries in Europe or other places have. And so I kind of had to build it for myself. And in that, I figured if I want to become the best glassblower, then I need to work for all the best glassblowers, and through that, gain that knowledge. So in my teens, in my early 20s, I was just seeking out mentors, taking as many jobs as I could, trying to get a very diverse toolkit to be able to make anything out of glass. And that also led me being really fortunate to travel around the world, working for the Corning Museum of Glass for 2 years off and on aboard cruise ships, which is a whole nother kind of crazy story, being on this massive ship, 1,042 feet long, 17 decks tall. But it was a really incredible opportunity for me to be able to not only explore the craft parts of glassblowing, but also to learn about the history, to be able to communicate about it, talk about it with the public day in and day out. And it's something that I really love, is that ambassadorship and that taking that material understanding and the history understanding, but then spreading that knowledge, you know, bringing it to other people, seeing what the interactions can be. And that kind of brings me to today and what I do here in Seattle, and how I make my living. I'm a freelance glassblower. I work for other glass artists, artists in general, designers, architects, and every day is a little bit different. You know, some days I'm helping other artists make work on their team, like the shot here. This is one of my very fortunate mentors that I've had for a long time now, Martin Blank there in the middle in the silver apron. So every day is a little different. I'm either helping artists make their work, making their work for them, taking on custom commissions for architects and for designers. And within that day job, I want to just talk about a couple of the mentors that mean a lot to me. So this is Martin Blank. I'm going to show you just a shot of his work. Martin is famous, if you don't know his work, for sculpting some of the largest solid sculpted pieces of glass, I want to say in history. I feel pretty honest in saying that. It's hard to get a sense of scale. I would say that the figure in this piece is about the same size as Aya. These are massive, massive works. I think that just the figure itself weighs about 200 pounds. The books themselves are very large pieces. And working for Martin really helped open up this whole realm of possibility, of scale, of complexity, about pushing what you're able to accomplish in glass, and also working with large teams. You know, if you've ever met Martin, he's incredibly gregarious and outgoing. And that's been, you know, I feel very fortunate for that. Another person that's meant a lot to me, this is Rick Allen, sculpting a spaceship Pegasus. I don't know. I'm a huge sci-fi nerd, and Rick Allen's work, you can see here in this next slide, is making glass and metal sculptures of spaceships and kind of that like pop sci-fi aesthetic from the 50s and the 60s. And I really appreciated, Rick isn't a traditional glass blower. He's a sculptor. He has his work, he has these ideas, and then we work to accomplish it. And for me, coming from a traditional Venetian background, it has to be thin, it has to be straight, it has to be concentric. Working with all of these sculptors really opened my eyes to different ways of thinking about the material, different ways of approaching problems, and also knowing what is possible too. His wife as well, Shelley Musilowski Allen, who, you know, with Mariah here, I've been able to work with a lot. Both of these people mean a lot to me, have been incredible mentors. Her work is much more, I went too far there, much more figurative. She sculpts a lot of animals. She was traditionally a and I've worked on her team for 8 years now, and just being able to approach problems in the same way that I was talking about working with Rick, and kind of building that toolbox out really helped kind of diversify the knowledge that I had and that I was able to approach things with. And I put this shot in here, and one of the things I wanted to talk about is just in gaining all this knowledge and working with these people. It's amazing how much it's changed, you know, in the last 2 decades. So this is a shot of Davide Salvadori, me working in his studio in Milano. And I think it's so incredible. Davide Salvadori I've worked with for a while, and his family history goes back for 600 years, over 600 years, and being passed down through generations, growing up on the small secluded island of Murano and blowing glass. And you know, there's only 2 generations in between us, but the ways that we learn to work with the material are completely different. And the access that Davide had to information was entirely based on the environment he was born into, the family legacy he was born into, and the people he was in direct contact with. And that system is really definitely changing now. I mean, you know, we're having a meeting over Zoom here, which is incredible, and sharing our knowledge this way. And that really influenced how I learned how to blow glass. And I spent a lot of time obsessively watching glass blows, and I still do watch videos. I mean, it's like over breakfast, I'll watch goblet tapes, things like that. But this explosion of digital communication has really changed how we're able to change and pass on these craft traditions. I mean, if you look on Google videos, you type in glass blowing, over 19 million hits come up, which is incredible. I was really lucky to benefit from this, being able to watch and learn from masters all over the world. So the screenshot here is from Venetian goblet master Davide Fuin, working in his studio in Venice. I've watched this video obsessively dozens of times. And being able to learn from these diverse groups of people over the world has really influenced how I approach the material. So some of the work that I make, you know, still, like I said, really based in this traditional glass blowing Venetian vernacular. So producing thin goblets, really working on these small pieces, and developing the hand skills to shape these small, tiny, thin pieces of glass presents a lot of challenges for makers in glass and teaches you really quickly how to manipulate and how to work with the material. And I try to make goblets when I can as much as possible. It's really similar to musicians playing scales, etudes, things like that, just to keep the chops up. But it's also, I've noticed over time, I just had started with it as to, yeah, I guess I'm drinking out of this right here. Ta-da. I had just practiced goblets. I wasn't really attracted to the really frilly Rococo Venetian aesthetic, but I just wanted a pure technical exercise. But I've noticed that it's really how I approach blowing glass and how I approach the material. And I think you can kind of see it throughout the rest of the work that I do for myself with other people with Phirak. And so here's the work that I produce that is not Venetian in the same sense. And what I'm really interested in is combining glass and taking my knowledge of glass and combining with other materials. So the next couple slides are just going to show a selection of the work that combines glass and other materials. And I really love that interaction of the two distinct materials and letting them kind of find themselves, but then working in the design, you know, the small range of bottles that I produce. These are just copper rings that a bubble is dropped through while it's together and then shaped together. And a lot of this work for me really comes from a lot of time in hardware stores. I have a lot of tradespeople and plumbers in my family. And I spent a lot of early years growing up, my grandpa's small little workshop in the back, playing with copper and material. Really enjoyed the challenge of everyday objects and bringing them into glass, but then reimagine them in a different way. It's kind of a creative exercise. So the feet of these bowls, they call these Sputnik bowls. Yeah. The design from the Sputnik satellite, USSR launched in 1957. The legs are actually aircrafts from the hardware store. They were just used as traditional plumbing parts. You imagine the same ideas, same aesthetic with a 90-degree bend for the base here. And some of the last copper work I was going to talk about here are these more recent pieces that have been kind of loosely called conduit sketches. So this is basically just a studio shot that I wanted to share with you. And for me, it's looking at a lot of natural and man-made systems of organization. So if you look at conduit, ducting, pipework, kind of still riffing off that idea and thinking about how these systems are organized in nature and also by humans. And although they have similar goals of efficiency, of delivering resources, information, the output of those variables is completely different. And I love kind of this organic nature of glass kind of playing against some of the more factory-defined elements of the copper pieces. So here's a couple more just shots from the studio here. So these are all large diameter flamework rods. They're about 3¼ inch wide that are bent and shaped. And it's been really fun going from the hot shop, which is very different from the flame studio, and you know, passing on these different ways of working with the material. So that's some of the work with copper, but I also wanted to just briefly share some of the work I do with other materials too. So this is laser cut leather. I collaborate with a local design company here, some dear friends from a company called SML, which is a design build company that specializes in laser cut leather and wood goods.
No.
So this is laser cut leather. So a quick screenshot of the design here. And I love this idea of making these small intricate parts of a completely different material that's juxtaposed to glass. You know, it's soft, it's malleable, it's more organic. And then playing with the two of them, you know, we develop and a lot of that came out of a commission that the two of us had both taken on years ago, where somebody wanted to produce a constellation pattern from a specific point at a specific time. So it was kind of this funny thought experiment to take, okay, like this is this data from the sky and the constellations at this time from this place, which is all widely available online, and then display that in a 2D format that gets wrapped over glass. And so we took that concept and run with it for some other commercial work that we produce. These are like a series of camping photos that we produce that all have different localized mountain ranges. So from Seattle, this is the Olympic National Mountain Range, that's just west in Seattle. And that's taking data that's available and turning it into a scalable vector graphic that's then sized and cut and etched out of the leather and then adhered to the glass. And I love these ways of pairing technology, pairing data, and then also pairing a traditional craft, leather working, glass working, et cetera. But one of the other big things that digital technology has helped me with has been communicating with clients, communicating with architects, designers. Previously, I had always done hand-sketched things that I would deliver to clients, and I would labor over them for hours, and I never felt like they were perfect enough. And for me, gaining some tools and being able to communicate digitally has helped me be a lot more professional. So here's a quick wireframe sketch in Rhino. Here's the rendering. It's a 40-foot wall in a resin that's constructed out of 30-inch rondelles that are water jet cut down. Here's the quick mock-up there. And then what I love about this method of working is instead of going into the studio and producing dozens of prototypes that would get thrown away to communicate an idea, to communicate an intent, I can model something, we can agree on something as with the client, and then I can just go into the studio and produce one of these objects. And you really reduce a lot of time, energy, resources, and cost. So then I'm able to go to the studio and just produce exactly what I need to with that toolbox that I've developed. And I feel really fortunate, working with Phirak has really helped me in gaining a lot of these digital fabrication tools. And it's something that I've just really started working on in the last 4.5 years that we've been working together now.
Yeah.
So I'm going to pass it up to Phirak, and he's going to kind of talk about his work and what he's doing.
So yeah, I would like to start with this slide. I've always been interested in different materials as a way for me to understand how things get made or built. And clay is just one of those materials that's been used for thousands of years, usually overlooked as a material for the wood. But with recent technology, clay is a material that's making a comeback for designer and architect as a way to explore through digital fabrication. Just to give a little background of where I came from, I graduated from University of Washington in ceramics, and then I went and got a master in architecture at UC Berkeley. And most of the time when I was there, I was focusing on digital fabrication and material research. Right after I graduated, UC Berkeley recruited me to join the team called Emerging Objects, led by Professor Ron Real in that picture and his wife, Virginia. And this is our office lab studio. So this is kind of a little background of what the company, Emerging Object, we are a 3D printing think tank. We experiment with different material, different way of 3D print. While most people are trying to develop the largest 3D printer they could, we designed small scale 3D printer that print component that could come together and assemble. And designing a manufacturer to come up with a specific 3D printer that could extrude clay. So I was fortunate to be a part of that from the beginning. So artist and designer researcher has been looking at different way of making. Ceramic opened up a lot of possibility in 3D printing. And as you can see, this chart illustrated different way how to print any material. What Brandyn and I have been working on is called a additive manufacturing, fused deposition modeling, or FDM. And it's normally printed with plastic. So you like have a hot extruder melting out like a spool of plastic, and then it just print an object. But what we did, we came up with a 3D printer that could extrude clay itself. And we'll show some of that during the studio tour later. Repetition and customization has been a consistent focus on my research. This is like sort of the beginning of it all. While I was in Berkeley, this is just a hand extruded pattern that I like make a custom die for it and then rearrange into a different pattern. So my research uses clay as a way to bridge the gap between methods of production and new expertise in digital fabrication. all of that's kind of led me to this research, how to develop a one-to-one scale cladding system facade for buildings. So they're all serving different function, either load bearing, just for aesthetic, or like acting as a rain screen. And the project that I got recruited to join at UC Berkeley, it's this 3D printed cabin with emerging object. Due to housing crisis in the Bay Area, specifically in Berkeley, Oakland, we decided to come up with a design that if we could 3D print a cabin in a backyard. And this is the result of that. So my job was to 3D print 4,000 tile that clad over the whole roof. And so I spent about a year doing that. That was fun. And the front of the house is a different way of 3D printing. So this is another specific printer that we use. So a lot of it are 3D print with cement, grape skin, just anything we have laying around in studio. We just throw it all into this 3D printer and create like a series of planter or hanging planter. The interior is also 3D printed and with LED light back. And we're also experimenting with like, can we 3D print large scale furniture or 3D print coffee cup out of coffee, cotton candy jar, salt jar, or rubber. So anything that we could get our hands on, we just ground it up and throw in the 3D printer. This is a series that I worked on while I was at Emerging Object. In early 2017, President Donald J. Trump suggested that there was bad ombre along the border. And he was continuing to suggest that we would need to build a wall to divide Mexico from the United States. But his pronunciation of the word ombre sounds more like an ombre, which means it's a gradual blend of color from one to another. So this is a series that I combine like black porcelain with white porcelain and throw it all in one printer and have it create a gradient naturally. After completing my research with UC Berkeley, I decided to move back to Seattle and starting my own creative research. So I decided to partner up with a friend and start a company called Suon. That's a way to keep working and exploring 3D printing with ceramic. This company allowed me to bring the technology to the mass instead of like a small group of designer and researcher. But at the same time, I have the opportunity to keep exploring at a much, much smaller scale. And there are many ways to approach like how people design. This is one product that I use as a software that we're gonna look at it, dive deeper in it later. It's called Rhino with a bunch of plugins to create this thing. This is a screenshot of Rhino, how you so like a file, a G code for the printer to understand. So this is kind of like a snapshot of how things get designed. It's a bunch of like coding behind. Like it's not visual at all. It's just a bunch of like what do you? I don't know how to describe that components. Yeah. Yeah. Just as zoomed in how you, like if you want a pattern on it, there's a component that's like throw in this pattern and it would change a surface into a texture that you could print with. So this is a time lapse of a 3D printer sped up to print one object. I was fortunate enough to run into Brandyn moving back to Seattle because we both share the same interest in combining different materials together. And my background is not in glass at all, but we had the opportunity to get a residency at the Tacoma Museum of Glass to try and combine clay and glass together. This is like one of the earliest examples, like me just dropping a bubble into ceramic, and Brandyn like came with this image, and he convinced that we could do much better, which definitely a lot better from like where we began.
I can't, like, looking at this image, I can't, every time it makes me giggle. It's so funny. But it's also, yeah, like Phirak was saying, this is the first image that I saw that, you know, when we kind of reconnected, we're looking at this, he's like, this is what I'm doing with ceramics and glass. It's like, we can do so much better than that. Oh my God. And so what we started doing is Phirak was still in grad school at the time and just finishing up, and he would email, not everything is digital. He would mail me physical just boxes of 3D printed ceramics. Some of it was glazed, unglazed, all different kinds of clays, all sorts of random stuff. And I would get these boxes. I'm like, what is this? And in the same way that I develop a lot of my own work, it's usually at lunch, on breaks, all sorts of other things. And so during these breaks, I would just take these ceramics and I'd try blowing into one. I'd try preheating and blowing into it. And through some of this just sporadic experimentation, then also more focused stuff, you know, taking time once Phirak moved up here to like, okay, what if we do this? What if we do this? What if we do this? And eliminating variables, we're able to kind of develop a method of being able to successfully combine these two materials together. And like Phirak said, we were really fortunate to have a residency at the Tacoma Museum of Glass to really hone in and highlight, you know, what we were able to do with these two materials. The big part of this is that these two materials at this point were not compatible at all. The ceramic, you can see I'm holding in my hand, has a very, 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 very different coefficient of expansion than the glass. But we were able to figure out this process of not necessarily directly adhering the two materials together, but having them kind of catch in the groove. So they're actually successful. And, you know, I think at this point we have a 90% success rate.
Yeah.
They have a little, because they're not directly adhered together. If they adhere together, if they get too hot and join together, of course, just like any other dissimilar materials in glass, they're going to break apart. And some of the early experimentations that we had were producing these lighting pieces. And with this, we, in designing these and thinking about these, it was keeping the glass and the ceramic very, very different. And I just got lost. Keeping the two aesthetically very different. I mean, glass had this, and then, exploring these textures that we were getting with the ceramics and with all these other things. And then during the Museum of Glass residency, we really started exploring line quality, thinking of additive manufacturing, where you're depositing these lines. And, whether it's PLA, where you're printing plastic, or ceramic, a lot of times you see these little tiny lines vertically going up. And so it was like, okay, well, there's ways of getting that in glass too. So, putting spiral wraps on pieces, distorting those, thinking about that process, and having them kind of visually relate to each other a little bit more. So this is some of the work from 2017 from that museum residency that we explored this stuff and a lot of other concepts. Here's a super quick video that just shows some of the process. This is something that I really would have loved to show in California, in the hot shop with you guys. Being in the hot shop is a community event, and all the people in this video are people I love and deeply care about. You miss that connection. So it's nice that we can join each other digitally in the same way. Directly preceding me beating up this bubble on a textured plate is threading a piece of opaque colored glass in a single line that goes all the way down the bubble, kind of once again emulating the additive manufacturing process. So you'll see here in a second, I'm literally holding the ceramic in my hand, and this is just the process that we've developed after it's calipered to exactly fit together, and then bringing the two of those materials through that reheating grade. So you can see here from those previous pieces with those tall cylindrical dome tops, I'm producing that shape on the blowpipe, kind of dry fitting the ceramic on. And then there's a moment that you have to commit, you get the right heat, you inflate the two of them together, and then you, as slowly and kindly as possible, bring that ceramic through that heating from room temperature all the way up to working temperature in the hot shop, which is somewhere between 1500 to 2100 degrees. And then by balancing those temperatures, you're able to kind of keep them alive and keep them happy all the way throughout the process. So one of the other things that we'd worked on, just kind of show the scope of what's possible, is a process that we're calling a greenware mold. So instead of firing the ceramic, all the pieces previous were fired ceramic, is actually keeping it in a green state where it's bone dry, and investing it in sand like this, just to give it some stability, and then using it as a rapid prototype. So you can see here, sonotube filled with sand, A bubble is lowered through, blown really, really, really hard into that mold. But what happens is all the water that's present in the clay actually causes it to explode off of the glass, and then it's a lost mold process. So you're able to get a fairly clean surface and a lot of detail. So we were just briefly exploring some shapes that would be too difficult to try and make a mold of these very geometric shapes. I could never produce this by hand sculpting it. It's just as a different technique for being able to mold glass. Another possibility of things that we were working on here is actually just printing glass itself. As you'll see in the printer behind us, when we start to work with it, basically you can put anything in. You can print with it. We printed with Velveeta cheese. You've printed pancake batter. So we were taking traditional pâte de verre formulations, so things from all the way from ancient Egypt, but that were really popularized in France in the 1700s, I believe. And using these formulations and extruding them and printing them. So here's just some very basic infill designs that we would heat up on a ceramic plate, roll onto the glass. And something we were curious about is being able to reproduce them looking at these ancient Venetian patterns. So this is Reticello net glass, where two canes are produced, they're rolled up, they're twisted, they're stuffed inside each other. Highly complex process, but kind of jokingly producing those out of glass too. So this is Reticello that's 3D printed and then rolled and gathered on top of, so you still have the bubbles that are trapped inside of the glass. So there's this endless play of being able to do things. And the way that we produce work is often there's like 3 questions that we run through, and it always starts with what if, and then goes to, well, how do we do that? And then it's why. And sometimes people get caught up in the why and think it's nice to just play, just to make when you can, and explore that. And this kind of leads to the last things that we want to share with you, and kind of talking about with what Aya talked about, is earlier this fall of 2019, we were really fortunate to get a month-long residency at the Corning Museum of Glass in upstate New York. And Phirak and I made this wild decision to go from Seattle to New York. We drove over 8,000 miles in 2.5 months. You know, it wasn't just this insane once-in-a-lifetime trip, but it also allowed us to stop at colleges, universities, talking with colleagues and people that we had talked with or met or knew, and really make all these connections and do a lot of research and collaborate in preparation for this residency that we had in the fall. And so when we got to New York, we spent a lot of our time in research, but anytime that we weren't doing research in the studio, we were walking around this insane collection that Corning has of over 60,000 pieces of glass that span 4,000 to 5,000 years of glass history. And it's overwhelming. I mean, I can't recommend enough that you make time, if you're able to go visit the museum at some point. And I found in every time, you know, in working and being in Corning when I was on the cruise ships, and also this last month, I find myself always really drawn to the ancient vessels that they have in the very beginning of glass history. And some of the examples that they have date back to 4,500 years old, which is incredible. You know, the picture here is a small Hellenistic core-formed bottle that was used for perfumes and oils. They're commonly referred to as alabastron. And what I loved about this, and I think something that we immediately, when we saw these pieces, and I hadn't even made the connection, is that these patterns that were produced by adding threaded wraps and then raking through them 4,500 years ago perfectly emulate the looping patterns that are actually glitches in the software that we kind of curate and produce a little bit. And so it's funny, anytime that you think that you've invented something, you've done something, history has this wonderful ability to take you back and be like, no, somebody already did that 5,000 years ago, don't worry about it. But spending time looking at the alabastra was interesting, and it kind of gave a little bit more of a formal language that we wanted to explore, looking at that history, because these vessels were originally produced out of alabaster, where that name comes from, but then were at the same time produced out of clay and glass simultaneously. So we started exploring kind of that visual language. I mean, because they have, glass and ceramic are so similar and dissimilar at the same time. I mean, ceramic has a 29,000 year history, which is insane to me. And there's moments when which they go and they come apart from one another. But here's a couple images of some of the work still with the flamework clay, where the not compatible clay bodies, that we were exploring some of the visual language of the alabastra there. You can see here that the top pieces from that video, the top pieces, the neck and the rim of that bottle are solid glass that are coated here together. I really like the idea of referencing the visual and the historical aspects of both of those crafts, but kind of denying the viewer any sort of like functionality of these pieces. Like you're not going to go and like put perfume or oils or flowers in them. So this was kind of continuing to push the work that we had done previously at the Tacoma Museum of Glass and outside of that. But like I said previously, a lot of what we were doing in Corning was research-based. So I love this photo of Phirak. This is like perfectly encapsulates like the delirious state of spending like days and days and days and days and days staring at books in patents and theses and all sorts of different things, and finding different recipes to incorporate and change the clay bodies that we were using for coloration, for being able to include directly with the glass, and looking at all the different properties from plasticity for extrusion, coloration, post-firing, in all this different history. And, you know, we did weeks and weeks of different production samples and testing and trying different ways and being able to build this knowledge base and tweak formulations so that we were able to include the glass directly with the ceramic. And one of the historical examples that we looked at were pieces that were produced in the 1700s that were loosely called cameo sulfides, absolute pellet, a lot of others, predominantly in France and Great Britain during the time in which cut crystal was really predominantly popular, actually included tiny little ceramic castings of usually of portraits of famous people that would be included directly inside the glass. And so that was a really easy starting point to be like, wait a minute, like people already, once again, included ceramics and glass long ago. How did they do it? Because a lot of that knowledge has been lost, or the techniques haven't been passed down. So pictured here, it's hard to see from this image, the ceramic is actually inside the glass. And what we did is we took this image of Dr. Jane Cook, who is a dear friend and incredibly helpful in sourcing a lot of the scientific knowledge. She was the former chief scientist for the Corning Museum of Glass and also worked at Corning Incorporated at the Sullivan Park Research Lab for a long time. I think she has 21 patents at this point. It's incredible. So we took the image of her, we turned it into a height field map, we 3D printed a PLA, we cast it, and we included this. And this was one of the first tests of a compatible clay body for glass. So for all the glass nerds out there, being able to test compatibility, to test fit, oftentimes we use polarized film, and you can actually see, depending on the small halos of light and how much coloration, how much stress is being put on the glass by whatever's inside of it. So on the right is a piece that we were able to get access to in the collection. It's a 300-year-old paperweight made by Baccarat. I don't remember who the portrait is of, but if you look closely, the way to read polarized film and read stress in glass is you're looking for these tiny little halos. So if you look, you can see that there's these kind of tight spots of blue and orange that are emanating from that face. And that says that there's a mild to medium amount of stress being put on. I mean, this object has obviously survived for hundreds of years. And this is an incredible moment, and only really possible at Corning to be able to have this historical example, put it under, document under polarized film, and then also take our own examples that we've been taking and then see that you can see the stress is a lot less localized in our sample. So we're like, hey, we actually made a more compatible formula than was used in the ancient factories. And not only was it testing formulations, also testing methods of inclusions. So here's a short video of one of the early ways that we had tried including glass. So you can see here taking this fired piece of ceramic, putting it inside of a small little bell jar, sealing it around it. This is all really fresh work. I'll show you guys some of the live examples that we have here. These are some of the test pieces that's still really in it, but this is a 3D printed piece of ceramic that's been fired, that's been vacuum encased inside of a piece of glass. And then both of them are shaped hot together and then annealed. One of the things that we were interested in coming from this history of portraiture that was present from the cameo sulfides has been taking 3D scans that are available anywhere for free. So this is a 3D scan of the head of Michelangelo's David that we had just used as a test file for a while, because we're like, oh, like just print the David. It's something that's easy. It's a little bit more complicated than just a simple product. But there's a really interesting, path to explore there with portraiture that we're interested in looking at. This is the Venus de Milo. Also, once again, 3D scanned, imported, printed, vacuum encased inside a glass. Yeah, so this is kind of the latest work that we've been to go through. And, you know, as tough as it's been in quarantine to not be able to blow glass and not be able to work, it's been a great time for us to really dive into the digital side of things, into the 3D printing side. You know, we're able to send files back and forth to each other all the time in anticipation of coming back into the hot shop. And I know that I'm definitely really excited about exploring this stuff a lot more. Yeah, thank you. So this is my studio space. We're here in Seattle, Washington. I'm really fortunate to also use that. So I share a studio space with graphic designer and unique Beamster Leverance, who's incredibly talented, also our resident plant queen. This is my studio space over here. So you can see all sorts of wacky random objects. Here's some 3D printed pot de verre tests, all sorts of fun stuff. This is a 3D scan of our dear friend Nate Sambar that we were working on firing this ceramic. And these pieces are actually separate, if I can lift them off. So you can see here, scan of his head, graphite that's put on as a resist, and then placing glass on top of that using it as a mold surface. So just gilding that. These were just some tests and demos that we did for our classic Pilchuck. Workspace, this is the desk I spent too much time doing digital stuff at. I talked about the conduit sketches in my slide talk. Here's some of those. I just kind of composed them on the wall hastily with hot glue. It's amazing how strong hot glue is. Oh, it's so weird. I can see myself in the background of the video. More objects. This is where I do a lot of the copper working and other things. We kind of just threw out some of the objects here from the residency in Corning, as well as some of the tests we were able to do right before the quarantine, everything shut off. But here's a 3D scan of Phirak that is just barely emerging out of the glass. We were testing the compatibility as well for objects that were not just encased in glass like this, but that are half encased, because that's a whole nother structural can of worms when it comes to expansion and contraction. Adding coloration as well. This is one of the very first early attempts. Here's another one as well of overlaying color directly onto the surface of the ceramic body as it's being encased. So you can see here, here's a light gradient of color right there. You know, in our teaching and our experiments as well, there's all sorts of different ways that we've played. These are molds, and this is something I would love to explore more once we're able to get out and about more, is I talked about Fusion 360, which is a software suite, but the slicer for Fusion 360 is super incredible because, do you guys remember, I still don't know what those things are called, but they were like, you could, like at museum gift stores, you would find like, it would be like a T-Rex or something, and like it would come in flat sheets, and you punch out all the pieces and you kind of slot them all together and you have like this wood T-Rex. Basically in Slicer for Fusion 360, what you can do is you can give it any form and it'll construct that in any way you want it to out of those flat sheets. And then it gives you a PDF with all of the cuts and everything numbered for how it comes together, and a video for how to put it together. And it's free, which is incredible. You're like, the technology is already there, right? So these are some basic experiments that we had done. Let me flip this around. Let me try this for the third time. Here we go. So this was just a basic cone shape, but the idea being, how can we make molds that are designed digitally that are much cheaper and much more inexpensive to produce? You know, a traditional wood mold costs anywhere from $500 to $1,000 depending on the scale. This is like $8 in material. This is just 1/4-inch plywood that's been laser cut. Here's an example too. But all of these, you know, you could have this routed out of graphite, you could have this made out of steel and laser cut, but then you're able to get the same designed object for a fraction of the cost. Another one of those subtractive manufacturing techniques that's been done a lot. If you know Fred Call's work, he's really explored this and is really incredible. We've learned a lot from talking and hanging out with him. CNCing graphite molds. This tile, one of our class projects was design a tile, routed out of graphite, and then, you know, building and constructing these glass forms by stacking all of these small glass tiles. This mold itself, I think, took 4 hours to use, and then we can virtually, if we take care of the mold, get almost endless amounts of these objects out of them. So, you know, once again, talking about that architectural scale of work, the great Fredini, that's right. You know, how can we take these forms and stack them and create them to create larger larger structures, larger pieces. Moving on, all sorts of random weird tests, things like that. Lots of ceramic. Here's another Phirak kind of lurking in the corner here. Here's the printer. We'll show you guys that a little bit more. We'll do a super quick printing demo. That guy is a trip for sure. And then here's some other work. Some of the copper, these little conduit sketches that I've been working on. Phirak has been really obsessed with this tile, these tiling projects. So we'll kind of show that a little bit too. These are still very green, so I don't want to touch them too much. But these are some modular tile projects. That was actually, he talked about it in a slide talk, but it was the thesis for his graduate work. Here's some in call mode, hand thrown in 3D printed pieces. A book collection with lots and lots and lots of books. And then here's, unfortunately, we only have these 3 pieces. The rest of them are already in shows or in other places that we couldn't reach them before everything shut down. But I figured at least you can kind of see around the pieces a little bit more. So once again, you know, the glass and the ceramic aren't compatible. They're not joined together directly, but have this kind of a loose being held together, but are definitely all one piece in that sense. Ooh, do I have a favorite glass book, or could I recommend 1 or 2? Oh my God. There are so many that I love. If you're wanting to learn how to blow glass, these 3 books by Ed Schmidt. This is for decades been the Glassblowing Bible. These are handwritten books that he hand illustrated after visiting with maestros that explain how to blow glass and all of the different processes you can see here. He lives up in Bellingham. He's a great guy. I highly recommend these books. The Glassblower's Bathroom Reader is hilarious stories from the community. So those are like fun how to blow glass books. God, there's so many. There's so many. What are other ones I really enjoy? Livio Seguso's work. This is a book that I was fortunate enough for the 2010 GAS conference. I was able to go to his studio. I've always had such an art crush on his work, doing this with one hand. If you don't know his work, check it out. It's sublime. I was able to go to his studio, meet him, get a tour. I got this book from him, which is incredible. And his work is sublime. So I really love this book because it's been one of the first. A lot of this work, he's older, so a lot of this work isn't online in a very accessible, easy format. But these pieces are just, they're perfect. I love it. So that's a book I really enjoy as well. If I think any more, I'll try to point them out as well. Livio Seguso. Oh, yeah. Here. If you want to type it, Phirak, that might be helpful. Livio Seguso. Wait, not yet. Yeah, and then also share a studio with an industrial designer that does some stained glass work that's really incredible. Livio Seguso. We're getting the karaoke, that's it. Oh no. And then this is Shannon Wallach, who has who's a really talented, intelligent potter, does a lot of traditional wheel throwing and mold making, who does really great work for Shanman Clay Company, his name, and I really love his stuff. And a lot of the conversations that we have around producing from analog methods to digital methods are always really interesting. And speaking of, oh, this is so weird, I can see myself in 2 screens now. Phirak's gonna talk just a really quick demonstration of some of the digital side of things, from Rhino to how we slice things using Grasshopper as well.
Yeah. So we're just gonna briefly show you like what Rhino is. This is the software that Brandyn and I are comfortable using. This is how we digital model all of our model before converting into a code that the printer will understand. And Rhino is typically used for like designer architects all around the world, and it's actually based in Seattle, which is nice. So Rhino is a command-based software, and you generally just like the way I learn, and I'm assuming Brandyn do the same, just like through watching YouTube and then just typing out question. So like if I want to draw a line, I could just on the upper left-hand side, it's a command, you just type in curve, and it allows you to draw And now you have a curve, and you can switch view. There's 4 different views that you could look at. So from the front or the top, you could see how the line look on all the angle. And in order to create a 3-dimensional thing, there's many, many different commands. But if you have a curve to start with and you want to make a 3-dimensional object out of that, the command is Extrude Curve. So it just pop up a bunch of functions. But the top one, you just click that and you could make a 3-dimensional object out of it. And the good thing with Rhino, there's a bunch of third-party that build software plugged in to support what Rhino offer. And the one that we've been using called Grasshopper. And now it's part of the package that Rhino offer when you install it. Also, if you guys are interested in using Rhino, they have a 90-day trial that you could download to start playing around. So this is Grasshopper.
Do you want to briefly just explain like just as an overview? I mean, it's a parametric system, right? That's
yeah. So Grasshopper.
Like, how do you explain? Yeah.
Yeah.
So it looks really complicated, right? Like so many. This is like when the first time that I saw Grasshopper, the first time that I saw Rhino is like, how can I learn this? It seems so overwhelming. But once you start to understand the basic functions, it's relatively simple. And I think the preface for all of this is the beautiful thing with digital technology right now is so much of it is open source. So much of it is available. So it's not like we hand built every part of this. We've done quite a bit of work in this, but there's a lot of elements that you can learn from or that you can directly borrow or use and adapt and share. And that community is really fantastic. So Grasshopper, the way to describe Grasshopper is it's a parametric way of doing 3D modeling, which means that if you change all of these tiny little boxes that are inside here that Phirak's kind of moving around are all different inputs and outputs for different things. So if you tell it, hey, I want to take this shape and I want to apply a pattern on the outside of that shape, there's a bunch of different boxes to be able to kind of build that out a little bit. So it's just a different way of thinking about making 3-dimensional objects, but it's an incredibly powerful tool. So Phirak, do you want to show kind of like the basic way that this works that we have it set up right here?
Yeah, so this is already written into the coding. So what we can try and do right now is converting the model that we just made to your left and turn into a bunch of line with texture that based on this pattern that we just found online.
The wonderful thing that I really love about these systems is, for me as a maker, as somebody that is very visually oriented, there we are, is I have a hard time, like, in writing coding scripts seems like a very complex thing, a very complicated thing for me. But because of the way that Grasshopper and Rhino are laid out, it feels very intuitive for me as somebody that has kind of this visual kinesthetic way of interacting with objects. And it ends up being a very intuitive way, more so than you would think. So I highly encourage, if you're ever curious, you download the trial, watch a couple YouTube videos. I think you'd be surprised how fast you can pick things up.
So I'm just trying to play around, see if we could. It's kind of hard to see what the pattern looks like. I just have to mess around with it a little bit, but all this option that will affect everything that every time I move something, it's going to change physically in the model.
And that's the beautiful thing about parametric design is, at its core, you constantly can change the system which designs things and have that express itself in the digital file rather than having to hand build each new file. So instead of building all of these forms individually, we've instead built a system into which we can place objects, place images, place all of these different things that we can play with, from the repetitions, the amplitude. You can see the things that Phirak is editing right now, and you can see a real-time editing, see just right there, by changing the scope of how that image is overlaid on top of that form. We just completely changed the design, but we didn't have to redesign the entire object. We just moved a slider. We built this system as opposed to building the objects. And that's something where digital design has a huge impact, is in having the power of those tools here. And when you're looking at the Rhino viewport here, the red lines that you see is indicating what is coming out, the output of the Grasshopper script here. So the kind of gray form that we drew and then extruded up, that's the form that we built. All of the red lines are what Grasshopper is putting onto that form.
Yeah, so once you get all of that, there's a step that you take into a software that there's a bunch out there that you could just download, but the one we like to use is Simplified 3D. So that's a slicing software that convert 3D model into G code, which is what the printer would read. It's essentially a bunch of coordinate for the printer. But yeah, there's many way to model something. And even if you don't want to model and just want to get started, there's a bunch of software website out there that you just download model. The one that we use a lot is called Thingiverse. So that's already pre-made model that you just download and then slice, and you can just start printing.
Yeah, and that's a beautiful, I was talking about that kind of crowdsourced resource that people have. That's where, in some of the work that we showed in our slide talk, where we had the 3D scan, the high-res 3D scan of the head of David or Venus de Milo, things like that. We didn't go and scan these objects. They're just files that are freely available for non-commercial use online. And the beautiful thing is being able to take these digital primitives that can be incredibly complex, but then to be able to alter them, to change them, to be able to share them. So you don't have to have an incredibly large toolbox to be able to start creating. So I'm going to show you guys the 3D printer in action. Turn around, come on. Poking you in the eyeball. Here we go. Look at the model of that 3D printer. Wow. Da, 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 da. So this is the 3D plotter from DeltaBots. Right? And this is in the slide talk, Phirak was talking about being on the team to help develop these printers, which is really great because we get all sorts of parts and tech support. All of this is such an early access thing. We don't email DeltaBots, we just call the owner. It's a pretty small community, would say. The basic overview of this printer, like I said, this all works off of extrusion. So this is a very powerful stepper motor that has an input from this computer unit, which is all kind of a jailbroke rep system. Right? So basically, there's a little SD card in here boop, that goes in here that has all of the G code, those coordinates, those files that we were talking about. And you pick a program and it basically just runs through that set of coordinates while extruding at the rate that you told it to. So it's a pretty simple system. It's basically just a computer controlled Play-Doh extruder is the easiest way to put it. You have your X and your Y coordinates down here, and then your Z is controlled, the height is controlled by this this motion right here. So you want to run a file, Phirak? Oh.
And you could manually change it's set in Grasshopper, how fast and how much it's extruded, but this printer allows you to manually change all of that since clay is not consistent between each tool. It's always different. So you always just have to be there, watch how to come out and change things. Right.
Yeah, that's something that, like I was saying before, in the same way that as a glassmaker, you have to change how you're working with the material based on the material you're using. If the furnace is running 100 degrees hotter, you change how you're working. Depending on what clay we're extruding, we change the speed at which we're extruding at, the speed in which the program is running itself, the speed at which it's moving. So today, we are printing Midnight Black from Seattle Pottery. And it's gonna, for people that aren't ceramics people, this is always just boggles my mind how much it changes afterwards. This is what it's gonna look like afterwards. So this nice kind of a matte black. So coming down here. So once again, the printer's just running through this set of coordinates, right? It doesn't know anything besides that. It doesn't react to any other things besides that. So, making sure that it's set up in the correct way, but also that there's, you'll see that we use our hands to press down the clay to change things a little bit. But this will crush you. You don't you don't want to stick your hand directly in the middle of the machinery as much as possible. So the way this is going to work, it's going to print from the very bottom all the way up. So right now it's just forming these base layers here.
It's going to be 3 layers.
3 layers for the base. Yeah. And this is all stuff that we set up when we're slicing the file. So that's kind of the workflow of producing things digitally. Is you're modeling something in a CAD program, a computer-aided design program, but then you have to have this added step of being able to tell the machine that's going to produce that object what to do in a language that it understands. So a pretty common language is G-code that we talked about, that series of coordinates. And to do that, you need a slicer. And what a slicer does is it just takes all of the data from that 3-dimensional object, and then it turns that into something, the language that the printer can read, in a sense. Or, you know, if you're doing subtractive manufacturing techniques, something that that a router can use to route graphite, like those other molds, that a laser cutter can use. So you can see here, just putting down those layers. Every once in a while, we'll kind of clean up some of the little bit of excess. And you can see here, Phirak's got his hand on the speed button because we're constantly changing by watching what the clay feels like when it comes out of the tube here. Because, you know, these are sealed tubes that we pack with clay, but, you know, there's a huge difference in something that we pack directly from a pug mill, and there's something completely different about when it's sat in this tube for a week. It's much stiffer, it's much drier, and we have to change that, change the speed, change how much the printer is pushing in the same sense. Any questions so far? Is this all making sense to people? It's funny, I think people, sometimes in my experience, people hear 3D printing, they hear digital fabrication, they think it's something that's really fancy or it's really difficult or kind of out of reach for them. And like I said, this is literally a glorified Play-Doh press run by a computer that, you know, can print whatever we want it to. So it's not that scary, it's very approachable. What's the slicer you are talking about? We use, so in Grasshopper, we've produced something that works as a slicer, but pretty commonly we use Simplified 3D. It's not a free program, but it's a very good program. I think it's a lifetime membership. It's like $100, $150. Yeah. Very reasonable. It can do a lot if you're interested in doing plastic printing with PLA or ABS or any of those other ones. Or Cura is another one Cura's free.
And Mesh Mixer.
And Mesh Mixer too, and they all have different benefits and different pluses. Now, I was talking before about, I'm going to come right back to this, you won't miss much, about these, what I guess we're calling waffle molded pieces, these molds here. And the program that's used to produce these is also a slicing program called Slicer for Fusion 360. Once again, all free, which is fantastic. And that has a lot of really fantastic tools we could slice these files that we're printing right now, but we can also have it do this kind of a waffle molded constructed thing from 2-ish dimensional planes too. So I think once you kind of dive in, you start to see which softwares have a benefit for what you're trying to do. You know, sometimes things, like this might be easier in Cura, or this might be easier in Simplified 3D or Fusion. It really depends on what you're trying to do, but they're all pretty workable. They all can do all of the same things as well. So you can see here, we got through that base layer, and now it's starting to express some of those little glitches that we had talked about before. And that's one of the fascinating things. And when you look at the file, they look like spikes. They look like fuzz that comes out. But because of the plastic nature of the clay, you know, it causes it to droop and deform in the same way. So like if you look at this file, you can imagine the digital version of this is just a series of spikes that come straight out from the piece. But because, once again, of that plastic nature, they fall and they form these soft looping patterns. I think we had a couple more questions. Where did those go? Chat. Has porcelain been used for printing? Yes. Actually, that's something that Phirak, you've printed up. Yeah. Yeah, so for foreign Suon, Phirak almost entirely just prints with porcelain. What? Why would you print with porcelain? A lot of plasticity. It's very clean. It's super fine. Yeah. Is 3D Printer commercially available? Yes, it definitely is. Do you want to throw up a link for that? I think it's just deltabots.com or something like that. That are really fantastic. Yeah. Do all ceramic 3D printers produce the same loop pattern on the exterior of the vessel? Not necessarily. So we could run, that's a great question. So let me just move over here. This is a really simple file. We design all of these as textures, but they don't necessarily have to do that. So all of the 3D printers that work with fused deposition modeling that we talked about previously, they're gonna start down here and they're gonna keep extruding, and by the nature of that, you're almost always gonna get that line quality, right, of all those layers that are extruded. Now there's ways of programming what's called non-planar printing where it starts doing this, but that's a whole nother like can of worms that does crazy things. But it doesn't necessarily need this looping pattern. So you can see like this was one of the early tests we did at Corning where this was just like a broken cylinder. I was just using a lot of cylinders as test tiles. So once again, vacuum encased inside a glass. But it doesn't have any of the looping patterns, but it does have this kind of, this line quality that almost all 3D prints have in one form or another. So whether it's from this or some of these pieces over here, where we're just taking 3D scans of objects, they still have that sliced line quality that comes up and down like that, but they don't necessarily have the same looping patterns that we've created with work like this. So I want to come back here. You know, once again, I think we're 8 minutes into this print. You can see it moves pretty quickly, which is really incredible. So we're able to produce and iterate a lot of designs pretty quickly, which is definitely a benefit of the process. I mean, working with fused quartz happens at temperature ranges that are like very, very outside of what we would normally work with. There's a lot of like really incredible exotic glasses. Like I've been really curious about how to develop a clay body that we could use in the flame shop with borosilicate that has a lower expansion rate than what we currently do. Fused quartz has an insanely low expansion rate. I forget what exactly, like 5 or 10. Corning actually has recipes for glasses with negative expansion rates, which is really hard to wrap your head around. Yeah, right? It's like, it expands as it's cooling, and then it expands at a certain point within that. But when you look at the average of the graph, it's actually a negative expansion rate as an average. Insane, very, very highly specific things. But I want to show you guys our cup that finished a while ago. So here is our little mug. Ta-da! Super cute. It's watertight. We'll fire it. You know, of course, ceramics is going to shrink 10 to 13% or so. So it, you know, we'll lose a little bit of size that way, but it's perfect for my meaty, beefy hands. Yeah. Got a couple more questions here. You need a hydrogen flame, don't you, for fused quartz? Yeah. I have a couple of friends that do quartz work. I know very little about it. I hear it's very difficult to shape. I think it's very short. It has a very it cools off very quickly, heats up very quickly, and also wants to boil very quickly. I don't think anybody does any work that I know of with color infused quartz too. It's pretty much reserved for people making dab rigs, and as far as I know, and also like the high end of like scientific wear. But yeah, hydrogen flames because it's very, very, very hot. Super class. Whoops. Do you usually fire high fire or mid fire?
Depends on the clay.
It depends on the clay and the application of what we're doing. Cone 8, somewhere around cone 8, 5 to 8 to 10. We've done 10 too, but you're depending on the clay you're using, you can fully vitrify the clay, which is fantastic. But at the same time, it presents a lot of warping issues, especially because we have some thin walls in these pieces. And that makes it infinitely more difficult to blow glass into when the whole thing is like an oval or some weird ovoid. So we try to avoid, usually 8 is where we top out for most of the work. But some of the stuff that you do for foreign Suon or
that's usually mid-range. So
yeah, that's mid-range too.
6.
Great, yay. Well, if anybody else has any other questions, I'm gonna throw up my email.
Yeah.
Please reach out. We'd love to hear from you if you guys have any other questions or resources, or if you want to know anything else, I'm happy to share. So once again, thank you to Gas for hosting us, Ayaoki for all of her incredible work in editing this video and for hosting us, and all of you for tuning in. And we hope that we can all get together soon in person for the next Gas conference. Thank you.
Stay safe out there.